Okay, next couple derivatives here. First one is sine of x cubed. It's a kind of basic chain rule problem. So I need to do the derivative of the x cubed first. That is 3x squared times. Next function is sine of. So the derivative of sine of is a cosine of. And then remember, this slides in here, so I get my x cubed like that. And that's good how it's written, so I'm not going to simplify it. All right, so the next one is y equals sine squared x. So this is one for which I always prefer to rewrite it before I take the derivative of it. So I'm going to take that sine squared and put the squared as a bracket so I can see which function is the inner and the outer function. So I get sine x bracketed and then squared. So when I write it like this, you should see pretty clearly that sine is the inner function and squared is the outer function. So when I take its derivative, I will start with y prime, boom, and I'll do the derivative of the innards, which is, the innards is sine. So when I derive that, I get a cosine x times, and now the next layer is, I'll do my little scratch work, well, I'll do it down here, is, I like to think of it as squared, which would derive to 2 to the first power. I'm not going to write the 1 because it looks like a prime sign. But, so I get, oops, doop. Alright, I'll keep going. So I get 2 to the first power, and then this slides in here the same way that this slid in there. So I'm going to get a sine x like that. So when I reorder everything, I like to have the 2 out front, and then I get cosine x times sine x, and it's just a sine to the first power because I went down from that. If this was a fifth originally, then I would have a fourth here, and that fourth would show up here to be written in the original form that it was given to me. Alright, one more for this video. We have y equals ln of 5x. So this is also one where people commonly mess up part of the chain rule, the ln part of the derivative. So the innards, that is 5x. So y prime is the derivative of 5x is 5, right? And then the derivative of ln x, that derives to 1 over x. So when I've got an ln with a chain rule, it's ln of, right? So ln of derives to 1 over that of. So when I do my 1 over, then this whole 5x needs to slide in there into the bottom of that fraction, because that's what the ln is of, right? As opposed to just putting an x in the bottom. People like to see ln, oh, the derivative is 1 over x. No, it's 1 over of. So I get my 5x like this. That gives me 5 over 5x, which simplifies to 1 over x because the 5's cancel.